This is a recap for Tuesday, May 18th. So we started today by rolling the dice. So we rolled the dice. We were going to roll the dice 3 times. So roll a die, technically. A die has 6 sides to it. So it has the numbers 1, 2, 3, 4, 5, 6 on it. So roll a die 3 times. And we were curious what the outcomes, so possible outcomes. So we could get a 1, a 2, and a 5, a 3, a 6, and a 4. We could get all the same number, 5, 5, 5. So we were curious, well, what are all the possible outcomes? And there's really 2 ways to determine that. There's more than 2 ways, but 2 ways that we talked about. One is, we went with a smaller example here just to get started. So instead of rolling a die 3 times, we talked about a coin instead. So what if we had a coin and we flip the coin twice? So there's 2 ways that we thought about this. We could make a list, or we could make what's called a tree diagram. So the list might look something like this. On the first one possibility is that you flip the coin, you get heads, and then on the second flip you get heads. Then you get heads and then tails. Another possibility is tails followed by heads, and then tails followed by tails. So that's 4 outcomes. 4 possible outcomes. Another way to think of it more visually is through a tree diagram. So this is our first toss, and it could be heads or it could be tails. So what's important here is that we find all the possibilities. And we discussed that, well, yeah, it could land on its side, but we would just disregard that. So then after you get heads, you could also get another heads and then tails. After you get tails, you could get another heads, or you get a heads or another tail. So this is also 4 outcomes. So just seen a little bit differently. And somebody, period 1, said, wait a minute, couldn't we just multiply the number of possibilities, 2, times the number of possibilities on the second thing that we're doing and get the 4 outcomes? And yes, we can. So I'll pause there if you're trying to write any of that, because I'm going to erase it. So back to the 3 dice. We did this. We looked at the tree diagram, and it got ridiculously huge. I'll just demonstrate it really quick. You could get a 1, 2, 3, 4, 5, or a 6. Then, after getting a 1, you could get a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You're getting the idea. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then from here, you can get on the third roll 6. 1, 2, 3, 4, 5, 6. So each of the ends of these is multiplying out 6 more. So this is really this picture of multiplication and how it grows. So instead of doing that, we can just do 6 possibilities for the first roll times 6 possibilities for the second roll times 6 possibilities for the third roll. It's 216. So 216, if we were to make the list, it might look something like this. We could roll a 1, a 1, and a 1. We could roll a 1, a 1, and a 2. A 1, a 1, and a 3. A 1, a 1, and a 4. 1, a 1, and a 5. 1, a 1, and a 6. A 1, a 2, and a 1. A 1, a 2, and a 2. A 1, a 2, and just keep going until we got all 216 possibilities. So those are the notes that we took. Let's do one more. What if we had a number or a coin? So we'll just say we have a coin like this that we're going to flip. So that means it's heads or tails. And then we have a number cube. What would happen if we did both of those? How many different outcomes could we have? So flip a coin and then roll a number cube. We could have heads and tails. And then after heads, 1, 2, 3, 4, 5, 6. After tails, 1, 2, 3, 4, 5, 6. So there's 2 possibilities on this times the 6 possibilities on the die, on the rolling cube. So that's 12 outcomes. An outcome would be something like tails and 1, tails and 2, tails and 3, and so on. The other thing that I would like to do is I would like to make an answer key for the 5 problems that we did on the quiz. So if you missed class, you can, I would put these in your notes, and then when you get the report on Thursday, if you're doing the corrections, you have what to put on the corrections. And if you were in class and you just want an answer key, then here it is. So I think what we'll do is we'll just go to each one of these, and I'm going to write right on the top here an explanation of the answer. It says, how many outcomes are there for tossing a penny, a nickel, and a dime? And I'm going to make a tree diagram, which is what I suggest you do on your corrections. So here's the penny. Penny can be heads or tails. And then here is the dime. The dime could be heads or tails, heads or tails. And here is the, I'm going to go in order. The order doesn't really matter here, but I'll go in how it's written. This was a nickel and then a dime. So heads, tails, heads, tails, heads, tails, heads, tails. So 2 possibilities here times 2 possibilities here times 2. See how they just multiply together? And 2 times 2 is 4 times 2 is equal to 8. So 8 and B were the answer on that one. Okay, you want to hit pause there if you're still writing, because I'm going to go to the next one. Okay, that's the first problem in the quiz. The second problem in the quiz said how many different outcomes are possible for spinning the spinner and tossing the coin. So the spinner has 1, 2, 3 possible outcomes times the penny has 2 heads or tails, so that's a total of 6 outcomes, and that was C. All right. And there was a little bit of confusion on this. How many outcomes are there for tossing a penny, a nickel, and a dime? So that meant that you tossed all of them. So a penny followed by a nickel followed by a dime. So maybe a little confusing in the wording there. Okay, so this one had a bag of balloons consist of 47 white balloons, 5 yellow balloons, and 10 black balloons. What is the approximate likelihood that a balloon chosen randomly from the bag will be black? So I'm going to add 47 plus 5 plus 10, and I'm going to get 62. So 62 is the whole, and this 10 is the part that is the winner. So remember probability. So probability of black equals how many black balloons, that's 10, by all of the possibilities, that's 62. So if I do 10 divided by 62, I'm going to get 0.162. It's going to keep going on. I would just grab a calculator to get that. And that rounds to right about 16%. So that's where we got that 16%. And let's go to the fourth question. The fourth question said there are 16 sixth graders and there are 10 seventh graders and 16 eighth graders in gym class. The gym class teacher randomly selects one student to collect balls. In how many ways can choosing not a seventh grader occur? So I'm going to highlight a couple things here. You can even pause and try this one on your own if you want, but this is really important, not a seventh grader. So I'm going to highlight what's not a seventh grader. 16 sixth graders or 15 sixth graders and 16 eighth graders, those are not. And so that's what I'm looking for. So that is 15 plus 16, and that's 31. And that is the answer B on that one. And then the last one that we did, make sure I put the answer to the last one. Yeah, that one was B. Okay. And the last one that we did was the rules of a contest say that there's a 6% chance of winning a prize. 400 people enter the contest. Predict how many will win a prize. So 6% of there's a 6% chance of winning, so 6% of 400. That's the people that are playing. So 6 over 100 equals what over 400? Times 4 times 4, that equals 24. So 24 is C. Okay, I'm going to go and do one more thing that we did in class, and that is on Pear Deck, we did this. On card 2, if you want to go there right now to card 2, we wrote a little bit. We did a couple of cards on Pear Deck. So we put this. We put the number line between 0 and 1. 0, a 1, and then we put the words on that from the notes yesterday. And this is 1/2 or 50% or 0.5. This is 1 or 100%. So we put impossible right here. And this one is certain. And half is equally likely. Or as likely as not is another way to say that. And then here is likely in between. And we did have a discussion about how that is this entire zone. So likely goes from just anything above 50% to anything below 100%. So that's a big area. So things could be most likely or extremely likely or very likely would be up here, or just above equally likely. All right, and then down here, this is where we put unlikely. And just like the likely down here, we're going to highlight that unlikely is this entire zone from above 0 to below 50 and everything in between. So we could say very, very unlikely, extremely unlikely would be down here, moving up to close to just equally likely. And then last thing we did was we went here to card 3, and we, in the text box, if you go there right now and go to card 3, it's going to give you a text box, and I want you to name an event that has a 0 chance of occurring, another event that has a 50% chance of occurring, and another one that's certain. So we just put some ideas on this, some actual events. Impossible. Some people said it's impossible to roll a 8 on a 6-sided dice that has 1 through 6 on it. It's just not going to happen. Somebody said it's certain that today is Tuesday, or certain that tomorrow is Wednesday. Equally likely that you would roll a even number on a dice, something like that. So go ahead and type those in, and you should be caught up. Actually, one more thing. If you're watching this, please look at the announcement and look for your name to confirm that you have finished the math inventory. That's this list, highlighted in green, or that you still need to take it, and apparently it's still open and you can still take it. So that's this list. That is a recap for Tuesday, May 18th.